Okay, video number 2. So now we're going to look at statistics. So when we're talking about central tendency or descriptive statistics, we're looking at a couple things. So we're looking at mean, median, mode, range, and standard deviation. So again, a couple different slides on explanations about stuff, then how to calculate it, some examples, because you are going to have to go figure out all this stuff. All right, so when we're looking at central tendency, that's mean, median, and mode. Mean is just the average. Okay, median is the number that's in the middle of a set of numbers. Mode is the one that occurs most frequently. And then we're going to look at variations of your central tendency. We're going to look at the range. So you take the highest score minus the lowest score, and that gives you your range of scores. And then the standard deviation, which is how much a score deviates from the average score. So it's either like one standard deviation or two, or the ones that we're going to be looking at. All right, so again, mean is the average. It's most often the method that's used to describe a set of data. So what you're going to do, you just have to add all the scores, divide by the number of scores, and then you get your average. So it's easy to calculate. The downside of this is it's really easily influenced by extreme scores. So if you're looking at test scores and everyone's doing pretty well and they're all pretty close, but then you have somebody who makes a 12 and somebody who makes a 98, but most of your other scores are C's and B's, then that's really going to mess up what the average is because you have these too far outliers. Median is the score that separates the upper half from the lower half. So it's the middle. Big advantage, it's not affected by extreme scores because you're specifically looking at what's in the middle. You need to put your numbers in order because that makes it a lot easier to figure out what your median is versus just looking at all these numbers and just taking a guess. So if it ever asks you to calculate the median, just go write out the numbers like a numerical order and figure out where your middle is. If you have an even number of numbers that you're trying to find the median for, like this example, go back. Right here, you need to take the average of the middle two numbers. So you have 6 numbers that you're trying to find the median for. You take 35 and 40 and you take the average of those two, and that gives you your median. Mode, you're looking at which score occurs most often. So it helps when your numbers are, again, in order so you can see which one happens most often. So the kids are playing in the background. Meryl, can you keep it down, please? Thank you. All right, so here's an example for y'all. So the weekly salary of 6 employees at McDonald's are $140, $220, $90, $180, $140, $200. So for these 6 salaries, you need to go find the mean, the median, the mode. Okay, so this is a good practice. Pause it, figure it out, then come back and check your work. Okay, I'm assuming that you all paused the video, you figured it out, you did it all on your own, and you're not skipping ahead to cheat and look at the answers. So when you look at the mean, right, you take all of them, there's 6, you add them together, divide by 6. So the average salary is $161.67. The median, like I said, you take the numbers, put them in order. Well, you have 140 and 180 since we have an even number of numbers. So the two numbers that fall in the middle, you need to average them together. So when you add 140 and 180 and divide by 2, you get 6. So the median salary is $160. And when you look at the mode, you put them in order. Which one occurs most often? 140. All right. Also part of this is standard deviation. So we're going to look at bell curve. When you look at a bell curve and we're talking about standard deviation, you take your average score, and that's the middle of your bell curve. So everything is either going to be like 1, 2, or 3 standard deviations away from the average. So it's either 1 standard deviation to the left or the right, so above the average or below the average. It's 2 standard deviations above the average or below, or it's 3 above and below. Always, 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 1 standard deviation from the average is 68%. So whatever your population is, whatever the average is, 1 standard deviation, which is to the left and the right of your bell curve, is 68%. Always 2 is 95. Guys, can y'all keep it down for like 2 more minutes? Okay, thank you. Okay, so if we're looking at, let me move this, IQ scores. Okay, so if the average IQ is 100, this is what a normal distributional shaped bell curve looks like. If average IQ scores are 100, 68% of all responses are going to fall within one standard deviation of 100. So 68% of the population is going to fall somewhere within that 100 range. So you'll have 34% of people that are one standard deviation below the average, and you'll have 1/3 of the, or 34% of the population that's one standard deviation above the average. Okay, that's what the blue is. So one standard deviation is always 68% of your population. Two standard deviations is always going to be 95%. So if we're looking at all of our responses, you'll have the blue part, which is the one standard deviation, and then the yellow, which is two standard deviations. Hold on. So 48% of your population would be two standard deviations below the average, and then you'll have 38% of the population that's, 48, math numbers early in the morning. That's two standard. So the really thing you need to remember about standard deviation, one standard deviation is 68%, two standard deviations is 95%. And those numbers stay constant with any bell curve that you're doing. All right, last thing on statistics is the p-value. P-value is the probability that your results happen because of chance. So when you look at the p-value, the closer it is to 0, the more significant the results, meaning that it's less likely that the results of your experiment were due to chance, so that there wasn't some outlying factor that influenced the results of your experiment. So the closer it is to 0 for p-value, the better. Not like correlation, where the closer it is to 1 or -1, the stronger it is, and with correlation, 0 doesn't mean anything. So just remember, correlation is 1, p-value is 0.